Alright, in this video we're going to take a look at writing the equation for a hyperbola in standard form. So writing the equation by hyperbola in standard form is going to use some of the very similar techniques to that we used for ellipses. However, because of the minus sign in our hyperbola equation, instead of adding the absolute values of both y coordinates of the vertices, the one that's after the negative term will actually be subtracted from the right hand side. So again, just like with ellipses, it's probably going to be easier to see it in action in an example rather than in words described here. So example 2, part A, find the center, vertices, foci, and equations for the asymptotes of each hyperbola. So once again, we're going to start by getting the 89 from the left over to the right. So we subtracted from both sides. And much like in the previous ellipses video, I've color-coded the terms. So we want to find the vertex for the 9x squared plus 162x, which that vertex is at negative 9, negative 729. And then we also want to find the vertex for negative 16y squared plus 64y, which, as a friendly reminder, if you're putting this into a graphing calculator or as such, I'm encouraging you to type in negative 16x squared plus 64x, and that'll give you a vertex of 264. Now notice in this particular problem, the y squared term in this case, has the minus in front of it. And so what I meant in the previous slide was, instead of adding the absolute value of 64 to the right-hand side of this equation, we're actually going to subtract it from the right-hand side. And again, that's because of this negative sign in front of our 16y squared term. So when we write this, we'll copy down this value of 9 in front of the x squared. So we have 9 times x minus a negative 9 becomes x plus 9 in parentheses squared. Copy this negative 16 in front of the y squared, so negative 16 times y minus 2 in parentheses squared. And then we have our negative 89. We're going to add the absolute value of negative 729, but we're going to subtract the absolute value of 64. So when we combine those like terms on the right-hand side, we get 576. And we want this equal to 1, so if we divide everything on both sides by 576, we'll get x plus 9 squared over 64 minus y minus 2 squared over 36 equals 1. And here's what our graph looks like. So as we can see, it's opening left and right. Our center is going to be at negative 9, 2. We have our a squared is 64. Remember, with hyperbolas, it's always the one that's positive, not necessarily the one that is the largest. So again, our center is at negative 9, 2. A squared is going to equal 64, so a is plus or minus 8. We saw that this thing is opening left and right, so we're going to add and subtract 8 from the x coordinate of our center. And when we do that, we get negative 9 minus 8 is negative 17, comma 2, and negative 9 plus 8 is negative 1, comma 2. For our focal points, our foci, c squared is going to equal 64 plus 36, so this should actually be square root of 100, which is 10. So square root of 100, which is 10. Sorry, I apologize for the typo. We're going to add and subtract 10 from the x-coordinate of our center to get our foci, and when we do that, we get foci at negative 19, 2 and 1, 2. For our asymptote equations, we have, because it is opening left and right, it's going to be b over a, which we have 6 over 8 for our slope, which reduces to 3/4, so we have plus or minus 3/4, and x minus negative 9 becomes x plus 9, and then plus the value of k. So we have y equals plus or minus 3/4 times, in parentheses, x plus 9, and then plus 2, and that'll give us the equations of our asymptotes. For example 2b, we have 9y squared minus x squared minus 6x equals 10. This one already has the constant on the right-hand side, so that's one less step we have to worry about. So looking at our terms, we notice the 9 in front of the y squared is positive and the 1 in front of the x squared is negative. So finding the vertex of each of these, remember well, in this case we could enter in 9y squared, but just in general we'd want to use 9x squared. We get the vertex at the origin for that one. And for negative 1x squared minus 6x, we get a vertex at negative 3, 9. So because the x squared term has the negative in front of it, we're going to subtract the absolute value of this 9 to the right-hand side. So copying down the 9 in front of the y squared, we have 9 times in parentheses y minus 0 squared minus the 1. We'll copy that down. Remember, there is a 1 there. X minus a negative 3 in parentheses becomes x plus 3 in parentheses squared is going to equal 10 plus absolute value of 0 minus the absolute value of 9. So again, because the x squared had the negative in front of it, we have minus in front of this value of 9. So combining our like terms, we get 9 times y minus 0 in parentheses squared minus x minus 3 in parentheses squared equals 1. And in order to get in standard form, 9 times y minus 0 squared means y divided by the reciprocal of 9. So it's a little bit of an algebraic trick going from 9 times y minus 0 in parentheses squared to y minus 0 in parentheses squared divided by 1/9. Multiplying something by 9 is the same as dividing it by the reciprocal of 9, which is 1/9. So that explains, hopefully a little bit clearer, how we went from 9 out in front to dividing by 1/9 in our standard form. So here's what our equation looks like. Notice it's opening up and down because the positive sign is in front of the y, so it is going to open up and down. Our center is at 3, 0. So again, be careful, because with hyperbolas, if the x term has the minus in front of it, again, h is always paired with x. So 3, 0 for our center. A squared is going to equal 1/9. Again, a squared is always the one that's in the denominator that has the positive sign in front of it. So take the square root of 1/9, we get plus or minus 1/3. So we're going to, because it's opening up and down, we're going to add and subtract 1/3 to the y coordinate of our center. And when we do that, we get vertices at 3 and then plus or minus 1/3. For our value of c squared is 1/9 plus 1. 1/9 plus 9/9 is 10/9. And when we take the square root of both sides, the square root of 10 is just square root of 10. And the square root of 9 is 3. So we got plus or minus square root of 10 over 3. So we're going to add and subtract the square root of 10 over 3 to the y coordinate of our center. And we can just condense it into one long fraction, 3, and then 1 plus or minus the square root of 10 all over 3. So at least these have like denominators. So for our asymptote equations, we have a is 1/3, b is 1, and the center is 3, 0. With the hyperbola opening up and down, it's plus or minus a over b for our slope times x minus 3, and then plus 0 or minus 0, doesn't really matter. So 1/3 divided by 1 is 1/3, so we have y equals plus or minus 1/3 times x minus 3. All right, example 3, find the equation of the hyperbola with asymptotes at y equals plus or minus 2x and vertices at plus or minus 5, 0. So our vertices are at 5, 0 and negative 5, 0. That means our hyperbola is going to open left and right. So here's a graph of the asymptote equations along with our vertices. And again, because the vertices are left and right of each other, our hyperbola is going to open left and right, which means the positive sign is going to be in front of the x term in our equation. So a is 5. It represents the distance from the center to the each vertex. And because our asymptote lines intersect at the origin, or another way to interpret that is the midpoint of the vertices is the origin, we can count the origin as our center, and a is going to equal 5. So with our asymptote equations, if it's opening left and right, it's b over a equals our slope. And because we have plus or minus 2 in front, we don't really need to worry too much about the plus or minus in front of b over a. So we get b is 10, which means our value of b squared is 100. So if a is 5, and 5 squared is 25. We'll get x squared over 25 minus y squared over 100 equals 1. So actually a lot less work in this problem than in some of the other ones. Alright, that about does it for this video, and I will see you next time.